So hello Dr. Stefan and Anai. So we are Tech Tribe and we actually built a hospital management system for the DBMS final project. So we focus on the Kwabenya Health Center, which a few of us have visited, and actually it's quite a big hospital facility present at the periphery of the eastern region. And we kind of see the principal operation are more around host prevention, creative services and all, and it's working 24/7 to provide the best to Kwabenya community and its surroundings, that's Dome, Medina and all. And one of the few problems that the hospital have been facing from our conversation were like inefficient record keeping, limited accessibility, and very hard to like retrieve and modify patient information. So a patient that's actually been filled, it's very hard to refine when the patient was filled, what was the past treatment, and in a field where most of the names are very complicated and patients don't understand some of the things, it's actually quite hard. So with this in mind, we kind of started building a system that will kind of manage the patient history, manage appointment history and financial history, and provide some support to the staff to make sure that they can rightfully just focus on the patient information. So this is our database design, our conceptual database design, and as you can see, we focus on creating a few tables, with the patient table being a strong entity and the staff table being the strong entity and all the rest being weak entities. For some of them, we created generalization and specialization, but most of them had mandatory or generalization specialization. So in case maybe of an appointment can either be inpatient or outpatient. And one of the key things that we were working on during this database creation was that most people will come to the hospital via appointment. We do not consider people who are coming just as normal patients, because such normal patients may actually just come and be registered as a normal patient in the patient table. So our database, our DBMS conceptual schema was more focusing on people who will be having appointment through phone call and all, and also we didn't add it way through with the appointment were entered. So any form of appointment is actually perfectly fine. And now we went on to, so just a note, there are a few things that we may note. So this stands for generalization and all, and when you see, for example, this is a one-to-one relationship between the patient and medical record table, with the medical record being dependent. So this I mean dependency, and at least one patient having one medical record. So this is more of cardinalities, and same goes here. But now here is more of a one-to-many between a staff and appointment. So staff can have many appointments, but there's a possibility of having no appointment, so a staff can also have no appointment. And now we shared quite a few of all the other attributes that we built, besides the what happened after normalization, which is creating the generalization and specialization. We also shared with you some enterprise tools so that you can better understand our table, and the assumptions so that you can understand our thought process throughout it. And we also have the logical database design, which is quite straightforward, following our breakdown of all the tables in the conceptual database. And kind of we created some views, which I'll explain later why they were very important. So these are the functionalities. These are just a few snapshots of the functionalities we created. It'll be easier to just go straight to the SQL to kind of see how it is. So we have the patient. You may be surprised that it's actually a virtual, but it's actually an auto increment, because we use triggers for the patient and the staff table to have a more customized way of putting them, in such a way that all patients are starting with a PT to delimit that they are patient, and all staff are starting with an ST to delimit that they are staffs. And now if you notice that most of the other primary keys are auto incremental from a particular number to a particular number. This is to avoid the case in which some keys may be redundant or some keys may be quite same as others when we are calling them later. And now going into that, we have directly, so there's an order in which we started first by creating all the tables and the database before going into the population, in which we created at least 10 tables per weak entity and 5 tables per strong entity. But we actually use a quite intuitive way of filling most of the weak entity, because they were depending on the strong entity or any other table. So for instance, let's just glance through most of this table population already present in the logical and physical, and there's really nothing, all of these are actually already there, so there's nothing really new on them in terms of the data types, maybe enum and all, which are actually quite helpful when it comes to generalizing and specializing the table, to make sure that people from the hospital can basically understand how the database is functioning. And going now into the population, we started by populating some tables, and let's jump first at the views. So the views, we created the patient view and the staff view in such a way that a patient or some other person from the patient can view a few information, which is just the first name, the last name, the age, and the gender. And now in the staff view is generally just basic information about the staff, which are the first name, the title, and the office. And we did this because we believe that people don't really need to see the patient insurance number nor any other sensitive information about the patient. And same for the staff. No patient or any other person need to see information about the staff. They can just see basic information, and that will be perfectly fine. And going into the population, we added quite a few fields just to test out if the database is functioning. And now, as you can see, for the clinical staff, the support staff, and almost all other case of specialization, we made the selection more automatic. So this is just to set most of the stuff automatic, to create the table and to test if all of them are running. So throughout the code, you see that all the specialized table have automatic way of being selected from their generalized tables and inheriting most of the properties that they have already. So we created also quite a few number of queries. So the very first one is to check out the room, like to assign an admitted person to a particular room. We grab the medical information of a particular patient, check the patient's prescription from previous visit. We also wanted to create a report in which a staff can actually check out all the information pertaining to a patient. And we went next into checking the occupancy status of the rooms, checking the available rooms per department, because all the department have rooms, so all rooms are dependent on a department. And now we went into calculating the total cost and all. So we have a total of 9 queries, and it'll be way easier to just run them so that you can see by yourself. So it won't really take long. Let's start with the first one. The very first query. So the very first query is for updating, so you won't really see that, but if you run that particular table, you easily see it. And the second query is around retrieving the patient information, the patient medical record and all, where this is the patient's insurance number. So as you can see, those are the patient information based on this patient medical insurance number. And as I've said earlier, most of this information are generic. So as you can see, this patient have the same information as this other patient, just because their insurance number are generic. If I change it, the medical insurance of this patient, or if you change it on your end, you definitely see something different. And going into the second one, which is just checking the patient's previous appointment. So you can see for patient 005, this is past prescription, and these are kind of the past, the description, the medication and all. And same goes for this, like checking out a report on the past staff activities. So you can see this patient and this is the past consultation room. And just for this consultation room, don't be surprised if when you run it, you find a different number for consultation room. As I said earlier, most of our specialized table are having preset records. So most of the informations here are kind of, for this consultation room, we made it in such a way that we provide you a randomized number just to make it a little bit fun and interactive. And yeah, this is just checking out the room, and you can see this one full room, but all the others are actually quite empty, and also they are pretty much available, though they will say occupy when it reach a particular threshold. So going to the next one, which is more just checking the total number of rooms per department. You can see all departments have 2 rooms, and some departments that are actually having 2 rooms as occupied are having 0 as available and all. And going to the next one, which is more checking around the patient paid, and these are like the total costs that are to be paid by a patient. It's very helpful for billings. And now going to this is just like the staff per department. So this was just checking for this department, and here this is the staff present per department. You just have a limited amount of table population. And the last one now, which is more around checking which staff is in this particular department and what is his job. So this is what is coming out. So here is a basic UI just to show how the whole project is working. You can easily see that it's just around putting in your information. So the code that you receive most likely will have no root, no password, but everything else will be working. So you just put in your SQL root and password and you'll be fine. So let's just run it and see what it does. So in my case, it was already run. So I'll just stop this and I'll rerun my Streamlit. And from this point, you will definitely need, and yeah, a dependency that you need is definitely Streamlit and MySQL connector Python, so that everything can run all right. And now I am going to update the information of this person to Berekuso. So as you can see, it will say it's update, and at first for patient 001, the address is 123 Kwame Nkrumah Avenue, Accra, Ghana. But now when I reload it, it automatically goes to Berekuso. Unfortunately, we didn't have the possibility of making more queries on the UI, but that's something that we'll be looking forward to do. It was actually a very nice time talking to you, and you're welcome in case you have any question, or in case you just want to think like there's some creative functionality you want to add. Thank you.